Hello everyone. Welcome to BST African Electronic Surgery on a Sunday. And I didn't come to fix anything, but when someone leave his or her comment, and I'm reading all those comments, at one point I seen like a lot of people from the channel, they really don't understand how a variable switching power supply is working. This is a variable power supply, but this one is the switching power supply. That's the one which I'm using on daily basis to charge batteries for cell phones, laptops, even car batteries. And also I'm also using this to find short circuits on motherboards. So today we will explain how a variable power supply is working, and by the end of this video you know everything about an adjustable switching power supply. Okay, so let's start. What is here? This is my switching power supply, adjustable switching power supply. And here, this is some kind of motherboard, laptop motherboard for space, which I just took for the purpose of this video, because we are going to do all the experiments on this motherboard. Okay, so on the variable switching power supply, we have to understand one thing. Why is it is being called variable or adjustable power supply? Is because you can adjust voltage. Mine is stretching from 0 to 60 volts, and on the amperage is 0 to 5 amps. You can see here it's on 13.12 volts. We can adjust this 24, 32, 38, 42, 51, 62 volts. Okay, let's lower the voltage to 10 volts. So on top is voltage. Here you can see it's 0, 0, 0. We have 4 zeros. This is the column for the amps, but you can't see any amperage here without putting on the load. In order to have the amperage, you must have load. I think from all the theories, we have to understand the Ohm's law, because we are dealing with voltage, amperage, and resistance. You see these wires here, we have 2 wires. The red wire is the plus, and the black one, that's the minus. And if I'm to short the plus and minus here, let's short this. You see, we now have a amperage 2.8 amps or 2800 milliamps, because that's the current limit that I've set on this power supply. So depending on what you are doing, or either you are working on a phone board or a TV board or a laptop board, and depending with the type of with the power supply that you are working on, maybe you want to find, let's say, a short circuit on the motherboard. We have to apply the right voltage and the right amperage on a relevant power supply. And trust me, if you don't know what to do with the power supply, you inject voltage on random power supply, things can go very bad. I don't want to lie to you. So I touch these probes, there's voltage drop to 0 and is communicating the max current that I've set, and that shows that this power supply has got a short circuit protection, because even if I short pins like this, nothing can go wrong here. Actually, I can able to adjust the current 3 amps, 3.1, 3.3, 3.6, 4.2, 5.2 amps. I can even lower the current 3 amps, 1.5 amps. So that's the thing about the power supply. So now we have to understand few things. If you are charging cell phone batteries, you adjust to around the 4 point something, let's say 4.5 volts. With this range, you can charge many kind of cell phone batteries. Like, you know, when the battery is highly discharged, you put your phone on charger. In most cases, the phone is not starting. Why? Because there's no communication between the charger, the charging IC, and the processor. Same with laptops. There must be communication between the charger, the BQ chip, and the EC chip. If you have a highly discharged, like those new model of laptops where the battery is inbuilt, if you leave your laptop at 0%, the battery got discharged and discharged and discharged, and at certain point there will be no communication between the charger and the BQ chip. Even if you plug the charger, you can't charge the laptop unless if you come with the power supply and bring back the battery to its normal charging range. So that's what I'm using this power supply. I'm using to charge cell phone batteries, any kind of lithium battery, and only finding short circuits. This is the motherboard. We have the many 19 volts power rail. We have many voltages, 5 volts, 3 volts, 3.3 volts. We have the 1.5 for the RAM. We have the 1 volt, probably graphics, 1.2 for the processor, 3.3 for the PCH. So you have to check. First you check, you find out here, like here on this motherboard, you have so many coils which represent the power supply. Before injecting an adjustable power supply, we have to know what kind of power supply are you dealing with, especially on laptop motherboards. If it's the RAM power supply, you set your power supply to 1.5 volts. That's the max voltage that you have to set there. 1.5 volts, and you come on that power rail. If anything is wrong, you will see even at 1 volt, if there's anything wrong on the motherboard, you will see that there's a short circuit here. Stop injecting especially, you see, what I want to do, let's put the multimeter on diode mode. We want to check resistance to ground on these coils. Here we have 4 coils. This one is 158 ohms. This one is not grounded. This one is not grounded. Here the resistance is not like a low resistance to ground. You can see these coils, these ones. Maybe you can see these ones, 2 coils. I don't know what power supply is this one. I don't know. So what people they are doing, the power supply is set on 19 volts because people they know that most of laptops they are working with 19 volts charger. So because the laptop is working on 19 volts charger, that doesn't give you the right to come with 19 volts on every power supply, injecting voltage or trying to find out short. Let's see the current. Maybe it's 19 volts. Let's raise the current to 3.5 amps. Yeah, 3.5 amps, 19 volts. Here we have the charging port. You can come with the 19 volts on the plus of the charging port. You can see it's taking 14 milliamps, which is standby current. Probably this is a working motherboard, but you don't mind. That's not the idea. The idea is not to fix, but the idea is to know how you are playing with power supply on laptop motherboards. That's the whole idea of this video. So if I inject on the DC input jack 19 volts, it's taking like 10 milliamps standby current, which is fine. The board, suppose this motherboard is not working, and you try to press the power on button, the board is just stuck. Now, because you've seen someone on YouTube using a power supply to find short circuit, you come with this coil. You remember we tested these coils before. The coils were not shorted to ground. Now you come with this coil. You see there's voltage drop 4 volts and it's taking 3.5 amps. Let's go to the next coil. You see spark, smoke. You see smoke. So what I've done now, you see that smoke? What I've done now, I've just killed the motherboard. Everything that is on power on that power rail, I don't mind what kind of power rail is this. Probably is for the processor, because we have 2 coils. It is next to the processor. Everything on that power rail is gone. So you can't play too much with a variable power supply if you don't know what you are really checking. Now let's check those coils again, because already we have seen smoke. Bad things have already happened. Suppose this is a customer's motherboard and you've done such a kind of thing. So those are some kind of beginner mistakes. You can't just go on random things, checking the thing with the power supply. You have to know what kind of power should be applied on that power supply. Let's check here. Check the first coil. It's now 0. The second one is now 0. But when we checked this coil before, they were not shorted to ground. Already we have messed up the motherboard. Anything on that power rail is gone. So you can't really play with power supply if you don't really know what you are checking, and if you are not sure, I would say starting with the lower voltage will be fine. Even if you have shorted many 19 volts power rail, you will see that you will see the short even with 1 volt. So that's the thing about power supplies. Because I've seen many comments on YouTube. Someone was asking me today, I was watching your videos and you use the power supply. You remember that old video when I was fixing a Connex laptop? I found the laptop was not turning on, there was no power. And the next thing, I checked the battery voltage and I discovered that the battery was very low. What I did, I come with the power supply straight to the pins of the battery. You have plus and minus, clock and data. You skip clock and data. The minus, you see how I'm using my probes. These are my probes for the power supply. The red one is the plus. And on the minus, I cut the probe and I use this peg. Why? Because I don't want to touch like 2 probes. I can pin this to any. You see all these, even to USB. I can pin this to a USB port like this, and come with the power. I'm now using 1 probe. You see? I'm now using 1 probe. So that's what I did on my power supply. So that's the thing about power supplies. If you are to charge batteries, the black probe should be to the minus and the plus to the positive. And if you are to charge any kind of battery, when you inject, you must have some current there. Maybe I can test with let me look for 1 or 2 batteries. Let's see. These are cell phone batteries. Cell phone batteries, minimum voltage 3.85 and fully charged 4.4 volts, and the maximum charging current is 1850 milliamps, meaning to say it's 1.8 amps. So we can't go more than 1.8 amps. So let's try to charge this battery. But before, we have to see what kind of voltage do we have on this battery. Minus, plus. This is like a fully charged battery, 3.9. Let's see the other one. Minus, plus. 3.87. Okay. So let's adjust the voltage to 4.5 volts. 4.5 volts. And now let's see what current do we have. 3.5 amps. What is the capacitance of this battery? Charging voltage 2000 milliamps, that means 2 amps. So if you come with the 3.5 volts the battery will charge, but you'll be straining the circuit inside the battery. Probably you are forcing that battery to get power very fast, and you kill the internal capacitance of the battery. So you have to make sure that you look what is written on the battery. Is 2000 milliamps. So what we do, we adjust the current to the max current, which is 2 amps, because that's what is written on this battery, 1.998. That should be fine. Now let's try to charge the battery. Plus and minus. And the battery is taking 1.2 amps. You can see on the screen our battery is charging. So that's how you charge the batteries. This one, which is written 1.8, same thing. Let's lower the current to 1.8, 1.788, and let's try to charge this battery. Plus minus, and it's taking 340. Let's try to raise voltage a little bit. This is not a faulty battery. You can see it's taking half an amp. Why am I saying this is not a faulty battery? Because we checked it before. The battery is almost full. .93. So that's the thing about the charging batteries and finding short, trying to inject voltage on motherboards. If you are not sure about that power rail, the best advice is to go even to 1 volt. Set your power supply 1 volt around 1 amp. Nothing can go wrong. You can test any power supply on laptop motherboards, but going on the motherboard with your power supply set on 19 volts, you have to make sure that's the main 19 volts power rail where you are injecting. Otherwise, bad things can happen. The motherboard can go beyond repair. So that's the thing about power supply. Was many people, they were asking what kind of voltage are you injecting, where to put the probes. Obviously you put the probe where there's short, if it's a shorted power rail. If you are charging with the battery, the minus should go to minus, plus go to the plus terminal, logical speaking. So I clear everything about power supply. Hopefully this video is going to be useful to someone. So yeah, just have a nice Sunday, and fixing. Let's fix things, guys. Let's fix things wherever you are. Try to learn, and that in that way you get better each and every day. So don't forget to like, comment and share our videos. Also turn the notification bell for future updates. See you on the next one. Bye.